Hi everybody, my name is Kennedy Nykum and I am a student at Western Kentucky University. I am currently in the clinical optics class where we are learning the basics for optometry. Today I'm going to walk you through the refraction process using the Jackson Cross Cylinder, JCC. First, let's get some background knowledge of the subject. The Jackson Cross Cylinder is a technique used for refining the power and axis of the trial cylinder. It involves a special cross-cylinder lens that has a net minus power in one principal meridian and one net positive power in the other principal meridian. It allows for combination of spherical and cylindrical lenses. There are two dots represented on the lens, one red and one white. The red dot represents the positive 0.5 diopter, while the white dot represents the negative 0.5 diopter. And spherical and cylindrical lenses can be large, especially as shown here when light comes through. The interval of Sturm is the dioptric or physical distance between two focal lines. Directly between the two focal lines is the circle of least confusion. These two focal lines both represent the two meridians. The horizontal meridian forms the vertical focal line, while the vertical meridian forms the horizontal focal line. The location of the focal lines for each meridian is based off of this equation, where A is the ametropic correction, L'R is the image divergence at the retina based upon the axial length of one's eye, and Fe is the power of the eye in a given prime meridian. It is important to note that the spherical correction before the eye is a critical precursor for the Jackson Cross Cylinder process. The spherical correction should allow the interval of Sturm to straddle the retina. When the interval of Sturm is on the retina, the lens used to get it there is called the best vision sphere. The L'R is determined by dividing 1.333 by the axial length. The average axial length is 22.22 millimeters, which means that the L'R is 60 diopter. Using this value as a basis, the two focal lines can also be taken into consideration. Here are the two focal lines, with the circle of least confusion not on the retina. To perform the Jackson Cross Cylinder, we must use a spherical lens, as seen here. Once the circle of least confusion is on the retina, the JCC can be used. The Jackson Cross Cylinder has three main steps: power acceptance or power search, axis refinement, and power refinement. Okay, hello everybody. Here is my patient Abigail, and I'm going to move the phoropter in front of her face. Okay, I'll be showing you two different forms of the target. Okay, so over here, this controls the spherical correction, which is the best vision sphere. So this can turn either way, and you should start the Jackson Cross Cylinder with the best vision sphere, and you would put that in here. Now this is the Jackson Cross Cylinder. It can be clicked out while you're correcting the best vision sphere, and then it can be clicked in when you're ready for the JCC. And whenever this P is lined up with these arrows and moves with it, then that is when you are in power mode. So if the two spinners here are lined up with the axis, that is axis refinement mode. Power acceptance starts the procedure by seeing if the cylinder power is even wanted by the patient. The first step in power acceptance mode is to insert 0.25 diopter cylinder and test the acceptance in the 90, 45, 135, and 180 degree meridians. If the patient accepts the power in any of the meridians, go to step number 2, axis refinement mode. We are ready to begin. So first what we'll do is we'll add in 0.25 cylinder for our patient here, and then Abigail, option 1 or option 2?
Option 1.
Okay, so she picked red dot, and this means that our axis is in the right direction, and we can go ahead and go to axis refinement mode. We'll come back and pick up on power refinement mode and make sure that she has enough cylindrical power in there at step number 3. This step begins with asking the patient whether they prefer the red dot to the left or to the right. After the patient decides, the axis wheel should be turned 15 degrees in that direction. Continue testing the patient and turning the axis wheel until their direction changes. At this point, the bracket lowers to 5-degree intervals, and the same process is followed until again the direction changes. Bracketing continues until the patient cannot tell a difference, ideally in a 1 to 2 degree range. Step number 2, axis refinement mode on Abigail here. So the first step is to just move our dials to click in with our axis down here. So as we move this, our dials will move as well. We're currently on 90 degrees. Now for this step, it's important to just look at the top half of the JCC at the red dot at the top. And as she prefers, option 1 of red dot going that way or red dot going to the right, that is the way that we'll move our arrow in different increments as we narrow it down to the final axis degree. Okay, so let's start here. Abigail will rotate 15 degrees after we ask her. So option 1, Abigail, or option 2?
Option 1.
Option 1, so she wants to move it to the right. Here we go. Let's try this now. Okay, Abigail, option 1 or option 2?
Option 2.
Option 2. Once again, the red dot's going to the right, so we will move 15 more degrees to 60 here. Okay, Abigail, option 1 or option 2?
2.
Okay. Now we're going to go into axis refinement mode here where we will bracket between the 60 and 75. So let's go right in between to about halfway. Okay, once again, Abigail, option 1 or option 2?
2.
Recall that we are now bracketing between the 60 and 75 degree mark. We will continue going to the left and to the right as our patient prefers whichever direction, until we get to the point where the patient cannot tell between 1 or 2 degrees. Okay, so because Abigail picked red dot, which is to the right, we will now bracket between the middle of 60 and 75, and she preferred towards the 60. So let's go about 4 degrees up from 60. Let's try right there. Okay, Abigail, option 1 or option 2?
Option 2.
Option 2. Okay, so now we're going to bracket between that and the middle, which we'll just go a few more degrees, about at 66 degrees currently. All right, option 1 or option 2?
Option 2.
Option 1 or option 2?
They're about the same.
Okay, it looks like we have refined our axis. We are now on to step number 3, power refinement mode, where the cylinder is refined until the patient rejects the power by responding positively to the choice with the white dots. Remember, the white dots are towards 0 and the red dot is away from 0. And we're going to click in the P, and it is now in with our axis, so we are in power mode. Okay, so let's see, Abigail, do you prefer option 1 or option 2?
Option 2.
Option 2, she picked the red dot, so we're going to go ahead and add another 0.25 cylinder. Okay, Abigail, do you like option 1 or option 2?
Option 2.
Once again, she wants to add another 0.25 diopter. Now we have strayed 0.75 diopter over here from our original of 0, so we need to add in a positive, just quarter. For every 0.5 cylindrical in whichever direction, in this case we've been going negative, we need to add in a 0.25 diopter in the spherical. So we've added in from negative 0.25 to positive 0.25 to make up for that. Okay, Abigail, let's see now. Do you prefer option 1 or option 2?
Option 1.
Option 1, that is the white dot. So that means that we will go back down. She did not like that extra 0.25, and we have completed power refinement mode. The Jackson cross cylinder on our patient Abigail, and her final RX was +0, -0.50, and axis of 0.65.